Okay, this is Toby. I'm working on implementing closures in the Play programming language, and I'm gonna document it on this stream so that it can be available to me and other people later in the future. Okay, so the Play programming language. I'll first make a small example of what a piece of code that uses closure looks like, and then last time I did a bunch of work to do to color variable names in a program based on the scope, based on which scope a variable is declared, it got colored a different color. And that is important. We're gonna use that to implement closures in this language. But this time I'm gonna start from a different direction. And that direction is I want to know what code to generate. Yeah, I want to get the implementation of closures working, which would then inform what code would have to be generated. And the code generator is the piece of code that needs to be aware of variable scopes, like which scope a particular variable belong to. But before we can even do that work, we need to do the work I'm gonna do now, which is I had to get the implementation working. Okay. So let me show you what exactly that means. First, I want to show you what when you compile a piece of code in the Play language like this. When you compile this, it generates a JavaScript file. Okay, so compile. I don't know why we have this printout at this point. Let me take a look. I did not mean to put a printout in there. I don't think. Maybe it's some code in the generator. Yeah. Oh, I'm testing the closures, but I'm not done with that part. So I'm gonna take that out for now so that we get a cleaner printout. Okay. So when you compile hello.play, you get the AST file and the JavaScript file. I'll show you both of those files. The AST file looks like this. If you've seen me work on the Play language, you might have seen this. It's an abstract syntax tree of the program. And then the JavaScript file looks like this. Okay. There's a lot of stuff in here. A lot of it is runtime library code, which means it's code that get packaged up with every single Play program. At least that's so I called, at least that's the plan at this point. That's the scheme at this point. I might change that in the future. So I called this section the runtime function section, which goes from here all the way to... We're not done. Oh gosh, there's more. All the way to here, actually. Yeah, and then this is the actual Hello World program. This is the one-to-one, and I actually don't know why this is indented right now. That seems a little strange. It shouldn't be indented. I don't feel like it should be indented. But this is the actual program that this Hello World program got translated to. And yeah, there's a print function that is called, which just in turn just calls console.log. Why is there so much complication? Well, I will explain part of it, but probably not all of it. There's a time traveling debugger user interface, which you can see. If you haven't seen that, you know what? I'm gonna show you. Let me compile the chessboard program. Actually, I'm not gonna show you. I don't want to get too off track. If you want to see this debugger in action, then go watch the Dream of the Time Machine video that I made. Okay. There's a bunch of code for virtual DOM manipulation, which has to do with interfacing with the DOM. And then there's user level functions, as in the programmer of the language can use certain functions such as print, listen to, get key, get value. These are user level functions too. Any function here that doesn't prefix with a $sign is user level function, which means the programmer can call them. So this is, and the functions that have a $sign in front of it, those are not user level functions, because in the play language you can't use a $sign in your identifier names, so this automatically prevents them from using these functions. But these functions are support functions, which are called by the program because the code generator generates code to call these functions. So PushFrame is a function to create an artificial stack frame, because the runtime of this programming language doesn't use the normal JavaScript stack frame. It uses a synthetic stack frame. So let me think. I'm gonna not go too deep into all of this details, because then I'll get sidetracked, I feel like. Okay, if you want to dig more into this, then I suggest you watch the three intro videos in the playlang repo there. Yeah, so I'm actually not gonna get too deep into how all of this stuff works. So I got three videos here and one more that's called The Dream of the Time Machine. Okay, now I'm gonna try to get into working on this. Basically, I will need to figure out what I need to do. Do I need more support functions for the runtime to implement closures? What? This thing being indented, it bothers me a little bit. I'm gonna try to fix it real quick, so bear with me. So that should be in the generate code function, and the code that's generated, it should be this one. And generate code for code block. Yes, I think it should have been this one. Why has it been indented? Async function main. Alright, let me async function. going to. I think I understand why this has been indented because. So this, I guess, this code indents it. Oh, the generate code for code block. Oh, I see. Okay, it's just this thing that indents it. A code block. Yeah, I'll explain what a code block is. A code block is an AST node of type code block. It's got statements inside it, but I'm also doubling the program node as a code block because it also got statements in it. So that's what it is. When we generate code for this code block, it loops through all the statements within the code block, generates code for them, and this guy had this indentation in it. If we removed it, what will happen? Then this code, because the whole program is a code block. How should we fix this? One way we could have fixed it is go to every place where it says generate code for code block, and then we yeah, I think that's a good idea. 1 second. I think I should put the indent here. I think we have more though. Oh, I know what I do. I separate out the program case from the code block case, and in the program case I'm gonna not indent, but in the code block case I will indent. Yeah, I think that's a good idea. And maybe I oh, instead of calling this directly, I'm gonna just recursively call this, and this guy will indent because it would encounter this if statement and indent it. Let me try this. I broke something. Uh-oh. Something hasn't been closed somewhere, but I have no idea where. It might be the place where I added an if clause. Yeah, it's probably here. There should be an else if. Okay, that worked. That doesn't look right totally. This is a try. Finally. Oh, I see. This doesn't indent now. Okay. Alright, I'll indent here. Any other callers of this function that would need indentation? Okay. Okay, I like this. I like this code better the way okay. let's go with this. So, all right, that was just a little thing that bothered me, that this whole thing got indented over, and now it's not. Okay, so that's a Hello World program converted to JavaScript, along with all these support functions. This is really the code that was translated from the program in play over to JavaScript. And then this little code here is just to, well, this calls the main function and catches it, and when the program ends, it'll actually save the history. And this is the code, the text of the original code for the debugger to use. A closure example here. Okay, this is a fine closure example, but even this is slightly complicated. I'm gonna simplify this. So let me move this. Let me say maybe there's a counter, and we're making a button, and we need to append that button to the body. Okay, I'll move the counter to the beginning. All right, we made a button. We should probably give the button some text. Like click on it. Okay, so now we have a button. We're gonna listen to the click events of the button. Let me get rid of this. All right, and then every time you click on the button, it's gonna increase the counter by 1, and then instead of, let's make a label. Okay, I made a label, and also let's append that label to the body. Okay, I'm gonna update the text of the label to the text of the counter. Let's see if that works. I'm gonna compile this. I mean, I know it won't work. I'm pretty sure it won't work. But this should at least compile. But when we actually try to run it, because closures don't work, it's not gonna work out. But we do get this code translated to JavaScript in this way. All of these saves are basically taking a snapshot of the state of the program and saving it into a history entry in a history array somewhere. And we may need to get a little bit into how that works in order to implement this, but I will give that information to you on a need-to-know basis. Example. Okay, so I'm gonna have this test HTML. Okay, is the stream still going? Okay, excellent condition. That's a good thing. All right, so okay, it executed all these lines, and that's fine. But if I click on stuff, well, that doesn't even update the debugger. But because my debugger was actually not designed to continually track activity on the screen, and I'm not gonna fix that at this moment. But we do have this history array, which every time I click, I believe it increases in size, because the tracking of state changes still happens, and every time I click, the code goes into here. We can actually set a breakpoint. We can actually set a breakpoint in this click event handler. So if I click, we get this breakpoint stuff and can step through this code line by line. Oh, I just step into the push frame. So if we do a push frame, we actually make a change to the stack. So the stack currently is an array with one element, and it's the top level stack. Another thing that would have to change when we support closures. Okay. So we can step through this code and see it go, and every time it calls save, it'll put another entry in this history array, which is how the history tracking works, or at least one aspect of how that works. Okay. Let me see. So my plan. So I just realized there's another thing I needed to do, which is we can't when it is a when this callback handler gets called, we actually can't use push frame in the normal way, because currently push frame pushes to this same. We basically need to, although it's curious that the stack did not get cleaned up, because I would have expected this the frame associated with the main function to have gotten deleted due to this PopFrame call. I wanna debug that. PopFrame should have popped this frame, and then we should have nothing. We should have had nothing in this stack array, I believe. But that was not true, and I don't understand why. Okay. It could be because after PopFrame we didn't have another save. Okay, let me add another save then. I'm not gonna change the line number because the original program. Well, okay. I could change it to 14. I don't know, like. Nah, I'll put it as 13. Okay. So if I ran it now, then the stack should be empty. Yes, I was correct about that. Okay. So maybe we should do that. After the PopFrame happens, we should save or possibly okay. Anyway, that was not too hard to fix. Let's go ahead and make that fix. Because I don't want that bothering me. So after this PopFrame, I have another save statement. And now I'm gonna recompile that program. And now it has it now, and it has in both places. Okay, and alright. That solves that quandary, and now the stack is empty after having executed the whole program. And now when I click, let's see, when I click, then when it's pushing the frame, the stack has one thing in it, which is the anonymous function, and that's correct. Okay. We still have to worry about asynchronous functions, and I'm not sure how to deal with that yet. We haven't considered that case at all in this programming language, but that's not the focus for today. Let's get back on track. So, all right. So my plan is, first of all, we need to figure out which variables are the closed variables. What are closed variables? Well, those are the variables that the inner function uses, which are not defined within the scope of the inner function. So the inner function is reaching outwards to the parent scope to get access to these variables, and I think the coloring thing can actually help me now. So I made a color vars script yesterday, right? Or not yesterday, last week. Did that even work? How did I do it? Traverser, color vars, yes. So okay, but I think cannot find playling closure. I'm gonna compile. Well, I already did compile. What's wrong? Who is requesting that closure module? Oh, it might be this one. No, who? This is internal Bootstrap startup. I don't. Oh, this one. Alright, I wrote that on the command line. Okay, I'm meant to call color vars closure example that play. Okay, and the colors. I'm not sure that worked out. Oh no, it did work out. No, that's correct. But we only have one color. We only have one color. So to show you a different color, let's say I'm gonna say counter. Let's say display is current count colon and then plus the counter. And then we'll set the text to the display. How about that? So I need to recompile the file first, and then we'll color the variables. And now you can see, okay, the display is a different color from the rest of the variable names. Is a different color because display was declared within this inner scope, whereas all the rest of the variables were declared on the outer scope. Now, if we go through the referenced variables within the inner scope that were declared in the outer scope, those are closed variables. So that includes, that's a different diagram. And that includes the counter variable and the label variable. Both of them are the closed variables of this inner function. So, and we need to give that guy special treatment. What special treatment will we give it? Well, we want to say, actually the current scheme is when you say set variable and get variable. Excuse me. Okay. When I say set variable and get variable, it gets it from the top of the stack. The top of the stack, but this time we don't want to do it that. We want to, because the top of the stack, it might have gone away, because as you have seen, once we pop the frame, then the stack associated with this main function is gone. But when you click on the button, you can still execute this inner function, even when the execution context of this main function is gone forever. Point before that pop frame happens and it's gone. We have to save them and preserve them for the purpose of the inner function to use. Okay, that is the case. So it helps that we have a program that's able to figure out what the variables we need to capture are. So I'll just write a comment here: capture closed variables, and we'll just hard code what they are for now. Okay, those two variables we need to capture, and how we're gonna capture them. One solution is, and also when do we capture them? One thought is we'll capture them at this point when we're about to pop off that stack. We'll capture them at that point, and then the inner function can use them. But what if this inner function gets called before it happens, which can happen in the case of map and reduce, because those are, like, if you do map this array, and then in this inner function, it refers to one of the outer scope variables, and if the capture hasn't happened yet because we haven't reached this pop frame for the outer function, then this inner function doesn't get to use it. So we can't necessarily do it at the end here. Is my feeling. We kind of need to do it at the beginning, and I think we need to put it on the heap. It's possible that we choose to, let me think. Maybe we choose to put these two guys on the heap. So call them and treat them as heap variables. And then for accessing just these two variables, we'll use get heap variable and and set heap variable instead of the normal get variable and set variable. Okay, let me think about that. Now we need to create a closure on the heap. Okay, yeah, let me give that a try. So we'll make a dictionary on the heap. And I think the way you do that is say heap allocate. Yeah, I think it's heap allocate. Like that. Let me make sure that's right. I can tell by just making a dictionary. Compile that and see what code it generates. Compilation is actually slightly slow. I wonder why. Okay, that's heap allocate. I'm gonna grab that and use it. Okay, I'm gonna use heap allocate and say, well, this guy is my dictionary, and I allocated it on the heap. I'm gonna get an ID from it, so I'll call this closed variables. I'll just call it closure, actually. Alright, closure. This will be an ID because the heap allocate stores this object or array in the heap, and then it assigns an ID to it. That's how this works. Yeah. Okay, I need to run into the bathroom for a moment. I wonder if there's a way to pause this stream. YouTube live pause stream. Is that possible? OBS does this. Okay. I'm not sure how to do it. I'm just gonna leave it running. I'll be right back. I am back. Okay. So where did I leave off? Okay, so I've created this closure, and my plan is wherever I'm using one of the two closed variables, and that was counter and label. Instead of using the set variable function, I'm gonna use the set heap variable. Set heap variable function. yeah, I'm gonna try that. What is not what I was thinking last night when I was planning to do this, but I think this might be a viable way to do it. So let's try this. So it's the whenever I'm setting the counter or referencing the counter variable. Where else am I referencing it? Oh, this is the only place within the heap. So should I pass that? What are the? Okay, let me. What are all these parameters that are getting passed to set variable? I'm gonna look up the set variable function. Actually, I can see that in the runtime, I believe. Where is the runtime? Runtime is here. Oh, I have a feeling that this compilation is slower, probably because I'm streaming, maybe. Okay. All right. Set variable. So, the line number. The line number is used here. It doesn't need to be. No. That's superfluous. We don't need this because I changed how the capture works. So that's actually a thing that we can change here. I'm gonna go ahead and do that. I'm gonna lose that line of work, but I'll save it. But I'm gonna change my first of all, I'm gonna change the runtime to not take that in. Second, I'm gonna change the generator to when it generates the code get variable. How many times? There's only 1, 2, 3. There's 3 places where it does that, and it puts in a line. Oh, it doesn't have to do that anymore. Okay, so I will change it to do that. Okay, and since that's easy to do, I wanted to do it right away so it doesn't keep on bothering me. Okay. So now, yeah, the set variable functions only take in 2 parameters now. And that makes more sense and is less confusing to me. Okay, so I'm gonna redo that step where I had this closure variable. Yeah, I think this is how I'm going to do it. So I have this closure, and I'm gonna say for whenever we're accessing the counter variable, instead of calling set variable, I'm gonna call set heap variable, and then I'll pass in the closure ID as the last argument. The reason we're using the heap is because an object on the heap will survive the tearing down of the function. So even after the main function exits, this dictionary that we put on the heap will remain because it's heap. It's for long-lived objects, and we're just representing that as dictionary. So if we had this function, then we're just saying add an entry into this dictionary keyed by the word counter and let the value be 1. That's what this function should do. And then now we're going to need to, we might use JavaScript's closure to implement this, possibly. Yeah, why not? I don't see why not. So because this const here, this const can be accessed in here because JavaScript has closure. So we can actually use that. So wherever it says set variable, we'll say set heap variable, and then put the ID of the closure there, and then also wherever it says get variable, we'll say get heap variable, and put the ID of the closure here. But only for those two variables, counter and label. I'm gonna get all the counter ones here. Heap variable, closure. Yep. And then for the label one, where we're getting, I'm gonna say get heap variable label closure. And there's probably another place where I am dealing with the label. Okay, these two places, so these will change to set heap variable closure and get heap variable closure. Okay, so that is the plan. I need to make these two functions. Get heap variable and set heap variable. Okay, what parameters do they have? Well, set heap variable has a variable name, the value, and the closure, which is an ID. And then get heap variable has a variable name and a closure ID. Okay. Okay. So given the closure ID, we need to access the thing from the heap. I think I have a function called heap access. Yes, you give it an ID, it'll access it from the heap for you, and there's no mystery. Heap is just this variable, this global variable called $heap, but I'm gonna call this function to access it, just because that's the scheme I have been using thus far. So heap access this closure ID to get the dictionary, and then I want to do an immutable modification, which means I'm not gonna modify the dict. I'm not gonna modify it like this to get the value on there. Instead, I'm gonna make a new version of the dictionary, spread the original dictionary on it, and then add a new entry to the new dictionary in addition to that. And then I'm gonna overwrite the heap. Then I'm gonna overwrite the heap with the closure ID. Overwrite the heap, that ID, the object with that ID with the new dictionary. So this basically makes a modification to the heap is what we're doing by replacing the object with that closure ID with a new one that has all its previous entries except also an additional entry. Or possibly it rewrites one of its existing entries. And then the get heap variable is going to be like this. I'm going to access it and then just read off the variable name and return it, I believe. So maybe this works. I'm not really sure. We can test it. Do I even see a label? Okay. Moment of truth. We're setting a heap variable. What is the heap even? this is the heap. So the heap is a dictionary with numerical keys, and currently this is taken up by the virtual DOM elements. So like this is a button element, for example, but this one looks like my heap. It has a counter. Let's just step through this code. So after it sets a heap variable to get heap counter, and then it's gonna add 1 to it. We should have the counter is currently 1, which it should be 2 after this line. Let's see if it's changed to 2. It did. Counter in the heap changed to 2. Yeah, this works. I'm gonna just let it. Well, let's step through it actually. Alright, step. This sets the display variable, which is not on the heap this time. This one is gonna be on the stack. And if you're wondering where the stack is, that's $stack. So that means the top of the stack has variables, and those are there's the display variable, and it has this string in it. Okay, and then we're gonna set text on the label variable, which is a DOM element, or at least a virtual DOM element, based on the value of display. Let's see if that works. It actually worked. This is incredible. So if I keep clicking, oh my god, this works. Oh man. Wow. I didn't expect to get this done that quickly, honestly. But that seems to work. I'm gonna need to get the code generator to generate this code, and it'll need to just know using the AST traversal logic, that the same kind of AST traversal that we did for the variable coloring thing. Use that logic to figure out which ones are need to be the closed variables, so therefore they need to come from the heap versus they are normal variables and go on the stack. However, there's gonna be one drawback to this approach, which is that for the purpose of this back in time debugger, the heap variables are gonna I'm not sure how to solve these problems, so I foresee 2 problems. I'll write it in the text editor. So okay, 2 problems that I need to solve. I need to solve. So one of the problems is the displaying the closure variables in the debugger. I need to do that somehow, because the current debugger is designed to very interesting. Does not display closure variables, and now we have to because while this function, like if we're stepping through this code, this is talking about the counter variable, and the debugger can't see it because it's not on the stack. It's on the heap now. So the debugger somehow needs to know about closure variables in addition to stack variables, and I'm not quite sure how it would know, how I would tell it that in addition to the stack variables, there are also closure variables. And also, it can get more complicated because you could have multiple levels of closures. Like you have a inner function, you can have this, this function def main. This function there's a bunch of code, and then there's maybe there's a blah blah blah. It has another inner function. Has a inner function, and then that's got some code, but then that has another inner function in it, and maybe this guy. Let's do some color code. Like let's say the main function declares a couple of variables, and then some of them are used here and some of them are used here, but maybe this middle function also declares a variable, and some of them are here. So I need to know that this middle function needs to capture this variable for this guy, and also that this top level function needs to capture these variables for both this guy and this guy. I think we just need an ID to mean the thing that contains these two, and then the code within here will reference that ID when it's getting the variable, and same with here. Yeah, I think that's doable. Just slightly tricky to get that right. And then we need to communicate that information to the debugger so the debugger can render the variables in the closures as well. Okay, I think I'm gonna stop there and go have lunch. It's lunchtime, and in the afternoon maybe I'll work on this some more.